Today we're going to look at recursive formulas. So a recursive formula defines the terms in a sequence by relating each term to the term before it. So far we've done explicit formulas. Today we're going to look at recursive. So let's consider the following sequence: 2, 4, 6, 8, and so on. Since each term in a sequence above is greater than the term preceding it, we can add 2 to the fourth term and find the fifth term is 8 plus 2, or 10, when we write the recursive formula for a sub n. Basically, you start with your a sub 1, which is your first term, so your first term would be 2. And then each additional term you're going to find using the previous term. So for instance, on this line here, we're saying the second term can be found by doing whatever the answer was to the first term, and then simply add 2. So in this case, we did 2 plus 2, so our second term was 4. Now, with a recursive formula, we're always looking at the term before it. So for the third term, we took whatever the answer was for the second term, which in this case was 4, so that's 4 right there, and we add 2. So 4 plus 2 would give us our third term, which is 6. And then for a sub 4, we're going to take the third term, which was the previous term, and add 2. So in this case, we do 6 plus 2, and we get 8. Basically, it's this formula right here. So I'm going to write this a little bigger. The formula is defined as a sub n. So for any term n, we're going to take a sub n minus 1, which is also known as the previous term, meaning the term that comes before it. So this is the previous term. And then in this case, we're adding 2 to the previous term. Whatever your rule is, we'll go after that. But basically, you find any term. So if I wanted to find the, say, 100th term, I would take the 99th term and add 2. In order to do these formulas, you need to know your first term. So it says a recursive formula for the sequence above is a sub 1 equals 2, a sub n equals a sub n minus 1 plus 2, and then there's some domain. The reason you have a domain is because if I tried to find the first term, you can't take the 0 term. So if your problem starts with the first term, you can't necessarily take a sub 1. Because then what would happen is you'd have the 0 term, which we don't have, so it doesn't exist. So let's look at the first example. They want us to write the first 5 terms of a sequence that has the first term of 7. And then they give us our rule. So it says a sub n equals 3 times the previous term, or a sub n minus 1, and then to subtract 12, and our domain has to be greater than or equal to 2. After all, they gave us the first term. So for a sub 2, this rule says to do 3 times your previous term. In this case, our previous term is 7. So 3 times your previous term, subtract 12. So if you were to put that into your calculator, that's going to give you 9. So far, we have a sequence that has 7 and then 9. Now we're going to find the third term. To find the third term, the rule says to do 3 times the previous term. So we're doing 3. Now when I go to do the previous term, I'm now looking at a sub 2. So we're going to do 3 times 9 minus 12. If you use your calculator or you do mental math, that will give you 15. So far we have a sequence of 7, 9, 15. Now we're going to try and find a sub 4. A sub 4, if you follow the rule, we're going to do 3 times the previous term, which we got 15, and then subtract 12. So if you do mental math or a calculator, you should get 33. And then our fifth term, which is the last one they ask us to find, we're going to do 3 times the previous term, which we just got was 33, and then subtract 12. And if you do the math, you should get 87. So we're always looking at the term prior. So for a sub 4, we looked at a sub 3. For a sub 3, we looked at a sub 2. For a sub 2, we looked at a sub 1. A sub 1 has to be given, okay? Because after all, our domain is restricted to greater than or equal to 2. So our sequence here would be 7, 9, 15, 33, 87. Let's look at another example. Here they're saying write the first 5 terms of the sequence in which a sub 1 is negative 2. So our first term is negative 2, and then they give us a rule right here. So the rule says to take negative 3 times your previous term and then add 4. So for a sub 2, we're going to do negative 3 times the previous term, which in this case would be negative 2, and then add 4. Okay, so here a sub 2 would be 10 if you did the math. Now we're going to find a sub 3, or the third term. This would tell us again with the rule to do negative 3 times the previous term here, which is 10, and then add 4. Okay, so a sub 3 would be negative 26. Again, you can use your calculator once you get to this step. You would just simply put the right side into the calculator. Let's look at a sub 4, or the fourth term. Again, we're doing negative 3 times the previous term, which in this case is negative 26. And then we're adding 4. So a sub 4 would be 82. And then we have a sub 5. We're going to take negative 3 times the previous term, which is 82. And then add 4. And that would be negative 242. So again, for the fifth term, we use the fourth term answer. For the fourth term, we use the third term answer, and it just keeps going. So our sequence here is negative 2, positive 10, negative 26, positive 82, and negative 242. If you notice the signs were changing. That's because we were multiplying by a negative. Up here, the signs stayed the same, positive throughout. So this is one way the Regents can ask. They could ask you to, using a recursive formula that they give you, they could ask you to list out so many number of terms. It's usually 3 terms, 4 terms, or 5 terms. But the other way the question could be asked is they can make you write the formula. So for writing recursive formulas, you're going to determine if the sequence is arithmetic or geometric. Just remember, for an arithmetic sequence, they're going to be adding a common difference. So that's why if you look at the formulas here, this is the arithmetic sequence formula. You're adding d, which is a common difference. And if you remember back to geometric, is multiplying. So arithmetic is adding, geometric is multiplying. So let's look at the first example. Write a recursive formula for each sequence. So remember, if it's recursive, it has to have an a sub n minus 1 somewhere, because that is the previous term. Okay. So the first thing we need to realize is here, is it going to be arithmetic or geometric? If you look at the pattern and try to figure out if it's arithmetic or geometric, what happens here is they're subtracting 4 over and over again. So this is going to be an arithmetic sequence. We also know that the first term is 17, and I just told you here if they're subtracting 4, our common difference is negative 4. That's really all the information we need to write a recursive formula. We're going to take the recursive formula up here for arithmetic. It says to do a sub n equals a sub n minus 1, which is the previous term, and to add your common difference. So if I'm going to substitute, I really only have to substitute for the common difference. So I have a sub n. So to find any term, you take the previous term, and instead of adding a negative 4, we'll just say, and you subtract 4. So we're taking the previous term, subtract 4. And then you also have to give it the domain and the first term. Because remember, you can't do these without the first term. So we'll say where a sub 1 is 17, and for n greater than or equal to 2. Because after all, if you don't have the first term, you can't do it. Now let's look at a geometric one. If you look at letter B, here your pattern is multiplying by 4. Multiply by 4, multiply by 4. So we're looking at a geometric series. We're looking at the first term of 6 and a common ratio of 4. So we're going to now use the geometric recursive formula. So it's a sub n equals your rate, the ratio, times a sub n minus 1. So your previous term times whatever the ratio is. So we have a sub n equals, and in this case we have 4 times the previous term. Okay, now you also have to give it its first term, so we'll say where a sub 1 is 6, and then your domain is for n greater than or equal to 2. So these would be your actual recursive formulas for each sequence. You could try some of these on your own, try some of the problems. The only thing you need to keep in mind is the difference between recursive and explicit formulas. Recursive formulas always use a previous term. So basically when you're solving these, you're always using the term before, and it's usually signified by a sub n minus 1. For the explicit formulas, those are the ones you did earlier in the year, you use these formulas. Explicit formulas are great because you could find any term without knowing the term before it. So if I want to find the 100th term, I only need the formula. I don't need the 99th term like I would for a recursive.